ride that you would sit in, like 2 rows of 3 people, and they would take you through the process of like getting the beans and then shipping the beans over here and then like going through, you would go through like the oven and it would get hot and you would smell chocolate. Uh, and it's like I enjoyed that from first grade to 12th grade.
All right. All right, gonna get started here. I picked this one because it was kind of an easy one. So it seems easy. We'll see. So I'm just gonna like think out loud. Yeah, I'll read through it. I'll kind of think out loud. I'll do my best. If y'all have questions or anything, hop in. Let me struggle. If y'all like figure out a solution, like write it down, make a note. Let me struggle for a little bit, and then I might go to like Stack Overflow to kind of let you see how I'm like going to try and figure out a solution. I'm going to try not to cheat in the sense of like actually just Google like what is the solution for this actual problem, because a lot of these you'll be able to find. But yeah, we'll see. If one like, and also if it's like too hard, I'll just skip it because I want to try and get through a few of them just so you can see like different ways of going about doing things. Yeah, and then we'll just see if like we want to break down the solutions, some of the other solutions that, because like that's one of my favorite parts about doing Stack Overflow is like you do your solution and then you see like some of like the crazy solutions that people like with crazy brains come up with that like know math and like know how to do all that kind of stuff. And then you see how like your solution actually is like pretty close to that in some ways. So yeah, all right, let's get started. Okay, so we're gonna find the screen size. Cheesy Cheeseman just got a new monitor. He's happy with it, but just discovered that his old desktop wallpaper no longer fits. He wants to find new wallpaper, but does not know which size wallpaper you should be looking for. And alas, he just threw out the new monitor's box. Luckily, he remembered the width, the aspect ratio of the monitor from the bottom owner or sold it to him. Can you help Cheesy out? So given an integer width and a string ratio, okay, that's important, right? Written as height, width times, or width height. I'll put the screen dimensions as a string written as width times height. Okay, cool. So I was like looking at like their examples and then sort of like what the input they're going to be using and what the output. So I could probably just do this one in here, but I'll just show how I kind of do it piece by piece. So I just have like a scratch.py file. And like, this is one that I was working on and practicing for this because like I'm rusty, y'all. So you'll see like there's some stuff that's going to be really basic that I'm going to have forgotten about. So, but that's part of this too. Like iron sharpens iron, right? So yeah, cool. Let's do it. So, and y'all should be familiar with kind of how I have my setup. Can y'all see this okay? Does this visual? Cool. All right. It's a little tight, but we'll try and make it work. All right. So first I'm going to come over here and sort of bring some of this over. So I want that. Okay. Because that's sort of what I'll be working off of and make this my life very easy. What is it? Width and height. So width and height, it's going to equal that. Cool. All right, so I got my variables set. Cool. Okay, so what am I trying to do? All right, so first I got to figure out how am I going to get this ratio. From this ratio, I'm going to get to this number. So I think it's what? It's 1024 times 3 and then divided by 4, right? Times 3 divided by 4. I don't know if that needs to be in parentheses or not, but we'll just do it. Okay, cool. So that gives me 768. Okay, so that's sort of like the formula I'm going to be using. Oh, I didn't want to close that. Oh, cool. Oh, I forgot. One of my cohort people, Monica London. She's awesome. I think she'll be at the alumni event that we're having in December. She got hired, so I just got a message about that. Very cool though. Very awesome. She's such a cool person. Like she was the all-star of our cohort. Great person and data scientist. Okay, anyways, back to this. Okay, cool. So that we got that. So that's sort of like what I need to figure out. All right. So I have this ratio. So what I want to do with that is I kind of need to break that up and sort of get those pieces out. So first, I think what I want to do. Yeah, okay. So that basically is going to be my numerator, my denominator. So I'm just going to label these D, N, and D. Okay, I'm going to get my ratio and I'm going to do dot split. And I'm going to do that on the, on that. Okay, so I think that should work. So then if I just print in, okay, cool, 4. Very cool. So now I can just basically do that. So I can make it height equals, it's going to be width times my numerator, but that's right now in a string, so I need to make that an int. Okay. And then I'm going to divide that by my denominator. So int D. Cool. That'll get me my height, right? Ah. D N. Gotta get that right. Cool. So 4, 3. So 4 is the denominator, 3 is the numerator. So there we go. There we go. There we go. Cool. All right. So then I just got to return that. So I think to return that, I'm just going to do an F string. It'll be the width. And then X. And then height. Why? Why did you do that? Let's see what that does. Cool. Okay. So it's right now, because of the division, it's a float. When you divide, I think it automatically will make it a float. So I just need to return that as an int. Cool. So I think that's it. If I bring this over here, this is like the hardest part, is getting the formatting right. I don't need that. I need this. Cool. Let's see. Let's test it. Nice. Cool. All right, let's go check out how other people did it. All right, using map. So what they do, they mapped int to that. Okay, cool. So that. Okay, so they just did basically what we did, but in one line. Similar there, they just indexed it with the 0. Floor division there, cool. If you do floor division, it'll automatically give it to you as an integer, I believe. Cool. What do y'all think? Any questions, any thoughts? That one was kind of straightforward. Yeah, I kind of got lucky with the ratio thing. I would have to think about that for a sec. I thought about that for a sec. That's why I chose that one. All right, let's do another one. Simple directions reversal. All right, let's check it out. So here, we'll just go ahead and comment that out. Cool. All right, in this kata, you'll be given directions and your task will be to find your way back. So solve. Begin on a road A, right on road B, right on road C, left on road D, equals begin on road D, right on road C, left on road B, left on road A. Whew. Y'all, this one's gonna be tough. All right. Okay. Wow. All right, so let me just grab that and bring this over. Oh, okay. Cool. All right, so I get that array. Okay, so it looks like it's all going to be the same sort of formatting by the test cases here. So that's good. Okay, cool. So then I think. All right, so what I'm thinking about is basically I'm gonna have to split this up. Each individual one of these things, I'm gonna have to split it into its own list, and then sort of concatenate the last two of the list because that'll be like the road area. And then the first two, so the middle is always on. So that's fine. So then it'll be like begin right, left. And then it'll just have to like reverse it. Okay, cool. Because I only have a couple directions I think I'm going to. I think I'm only going beginning, left or right. I don't think there's an up or down or anything like that. Cool. Yeah, so then it's just a matter of like figuring out the logic of if this, then this, putting it all back together, and then joining it back together as well. Whew, okay. Does that make sense in terms of how I'm thinking about this game plan? Okay. Now it's time to now the fun part, trying to figure out how to actually do it. Okay, cool. So right now we have this array. So I'm going to pull this out. And this is what we're going to start playing around with. So I'll call this R, since that's the term they're using. Okay, cool. All right. How do I want to do this? Because I don't know how long R is going to be. So I need to make sure I'm doing this to where no matter the length, I'm capturing it. So I could do a for loop and go through R and then have another list that I'm just appending the new splits to. Okay, so that's what I'll do. So we'll do R1 equals an empty list. And then, well, okay, well, we'll do some list comprehension. We'll try to do that live. Woo. All right, so I want to do R. So I dot split for I in R. Okay, what do we do wrong there? Oh, maybe define R. Cool. No, you're good, Zach. Okay, cool. All right, now let's see, what is R1? R0. Begin on road A. Cool, cool, cool.
So is your array full of lists?
Yeah,
Okay.
it's an array of lists. Okay, actually, I think this is going to be easy. So if it's begin on road A, right on road B, right on road C, left on road D, it'll be begin on road D, right on road C, left on road B, and left on road A. All right, how does that work? All right, so what I'm trying to figure out is just like the logic of how these are switching, because it might be able to just do it very simply. I'm sure there's actually an algorithm. I'm sure this is some computer science algorithm that I don't know. All right, so begin on road A. So then I'm just switching A and D, and I'm gonna just write this down. Unfortunately, I wonder. Let me try something real quick. Nah, never mind. I'll figure that out for next time. I think I'll be able to do like sidecar with the iPad and then like write on the iPad so y'all can see me writing. But I think I have to have an app for that on my actual Mac. But I'm just gonna write this out real quick. Okay. So begin A, and then R, B, and then R, C, and then left D goes to begin D, R, C, L, B, L, A.
I got a question. Why did you want to split all the lists?
I did that so I kind of have that modular. So then that way, like I can just go in to like my R1 0, and that would be this begin portion, right? And then I can index to this and join that together to have road A to then create a new string. Like kind of quickly, you know, because that's easier than if it's in the string and then I'd have to index based upon like this, like, you know what I mean? The string itself. But I'm trying to figure out like how I can figure out the logic of this. I might be thinking about this too much, too hard. So it might just be better to strike, like coding it out backwards, hard code it, and then there might be something that'll come from it. So let's try that. Okay, so if I begin on road A, so now I'm on road D and I need to get backwards. So I'm just gonna start, I'm gonna just draw out the little map of it. So if I'm at A, okay, and then I take a right onto B, okay, and then I take another right onto C, and then I take a left onto D. So if I'm on D and I need to get back to A, I go from D, I take a right to C, so on D, I'm taking a right to C, and then from C, from D, right, D, right to C, and then from C, taking a left to B, and from B, I'm taking a left to A. Okay. Okay, so first I just think I want to just get begin as like a word. Begin, cool. Okay, so then R, no matter what, R -1 will be my very last one, right? So that will be where I will always be starting. So I want to do R -1, 0 equals B. Maybe make that. Okay, so then R1 -1. Is begin on road D. Cool. All right, so that's where we're starting. All right. Now, would it be R? I guess I need lane R, length R, maybe, as one of my things. I need to know length equals length R. Cool. Because I think, all right, so my thinking here is I can just go sort of backwards, right? So then -2 should be right on road C. Okay, cool. So Okay, so I think whatever I did last, so I went left on row D. So that left means I have to do the inverse of that and then go right on row C. Okay. So, all right, does y'all get that? Okay, so like, all right, so then what I need to have here okay, I think I want to do this later. Okay, I'm gonna bring that down there because I think I want to figure out the logic first and then go in and change things. Because there's gonna be some if and statements, but I kind of want it all to be the same right now. So let me rerun this real quick. Okay, cool. Okay, I think I need, okay, cool. I think what I'm gonna do is another array. I don't know if this is gonna be the most efficient right now, but this is just, all right, because this is what's gonna happen. Yeah. Yeah, I'm just gonna make array 2 equal to array 1. I think I'm gonna just do dot copy because I don't want to mess up. I don't know if it will write over it or not, but I don't want to do that. Okay, cool. So this will be array 2. And array 2 is what will return ultimately, I believe. Well, join together. Yeah. Okay. All right, so then with this is array 1. Okay, cool. So if array minus 1, so if the last thing if array minus 1, -1, 0 equals left, okay, then array 2 minus 2. I'm gonna have to think about how to do this iteratively for like if it's like a length of 10, there's 10 directions. But right now I'm gonna hard code it like this, and I'll probably have to get this into a for loop somehow. Maybe we'll think about that here in a sec. Okay, so then array minus 2, 0 will no begin. So it'll be array 1. It'll be the 1 because this will be the very first thing. Okay. Oh, this might be confusing the way I'm going to be doing this, but basically I'm going to like mix and match the different pieces of the array. So I'm inverting it. So array 2 will be array 1, but the backwards way. And so right now I'm going to make array. So this will like array 0, array 2, 0 is the begin, right? So actually array 2, 0, 0 will be this, right here. Will equal begin. And then array 2, 0, 0, 1, 2, and array 2, 0, 3 will equal array 1, -1, 2, array 1, -1, 3. Okay. I'm just flipping it. Okay, so if that is left, then that means array 2, 1, 0 is going to equal right, and array 2, 1. Oh, what am I doing here? It's basically going to be the same as that code below. Maybe be thinking of how I can do this iteratively. And that's going to be array 1, -2, 2, and array 1, -2. Two, 3. This might be super boring for y'all. Cool. All right, let's see what this does. I think this is it though. R2 is not defined, of course. I'm terrible at running that. What? R2 is defined now, correct? Thank you. Right on road B. If R1 -1 0 equals left, R2 1 0 equals right, and R2 1 2 equals R1 -2. R1 -2 2 0 1 2, and R1 3 equals R1 -2 3 0 1 2 3. Why? All right, so 1, 3 is B. Okay. R1 -2 3 C. What is R1 -1 0? R1 -1 0. Okay. So then R2 1 0. Right? Do y'all see what's wrong here?
Are you trying to change something in your if statement?
I'm trying to like use this if statement to change my second array.
Because I thought the double equal sign is just like a true or false.
Ah. Thank you, Ruben. Goodness gracious. So there we go. Now if I print R2, that should be right on road C. Cool. All right. Now I'm going to try something. I'm going to try to do this like iteratively in a for loop. No matter the length. Because these are different lengths. Okay, so then I'll just do the else real quick. It'll be the same. I don't know. This one might not be worth keep going. What time is it? 44 minutes. All right. I don't know. Should I keep going with this one, or should I go to another one? Because this is kind of boring, huh?
I think that you could take another approach here, and there's a reverse function where you could reverse the list, and then you'd have two lists, and then you could split both lists and then just replace each index with the other one, and then that should give you the right direction.
Yeah, I was thinking of just doing one split and just splitting off the first word, because everything else you want to keep the same essentially, and you're just changing the first word over and over again.
But you got to think of it like it's not always like switching one for one. You see, like.
Well, if it's going left, the next one's right. I mean, you change left to right, and you change the begins. And you move it up
Right,
one.
but like even on here, see if I just because like I could just switch that, right? I could just switch road A and road B, and then switch everything. but it goes begin, right, right, left, and then begin, right, left, left.
Mm-hmm. So you do it. I was thinking you do an if statement, if left, switch to right for the next one. So you would iterate all of it. Kind of what Vinay was saying. You iterate all through all of them. You would recognize the left and rights, and you're moving all of them like kind of up one and changing it because you're going backwards now.
Okay, so
and then you can figure out your length with your R split because you're gonna have it's a list of lists, and so however many lists you have, that's your length for your for loop.
Right. So I have my length right here.
Yeah.
Okay. And then then do a for loop for I in length. R.
I think it's do range, or does it matter?
Yeah. Okay, then you're saying.
Say I wasn't that smart, and I was thinking like you can have a list of begin left right, and then you can have a couple if statements.
So just like literally a list of the strings begin left right.
Yeah, that's what I was thinking. And now you can kind of do your if statements, but if you change the way you split, just to split the first one, because you can tell how many times you want to split, right? It could be might be faster and easier to read because we want like whatever the only thing we're changing is the first string begin right left. We're not changing on road or on boulevard. Like it's all going to be the same. We're going to change the order obviously as well, but we want to keep that string together. And so if we don't have to iterate over those indexes, we only want array 0 0 or array 0 1.
Yeah, I gotcha. Okay, cool. Well, I still, yeah. So I still kind of want this.
Yeah, I think we still want all of it, but by changing it, it could be easier for us to conceptually do it instead of. So I was getting lost. I was like, whenever less numbers is hard, it's easier for me. Numbers are hard.
Okay, so I still have that.
Mm-hmm.
So then it'll just be like.
I guess also, what Vinay
I
was
want to
saying,
reverse my list now.
I think so. On array 2, you want array 2 to be reversed already. Right, array? Right, Vinay? I called you array.
Yeah. So I took the original list. I reversed it, saved it as the reverse list, and then split both strings. And then I created a for loop to swap the first item in each one, and that would give you like the reverse directions. I think so.
Perfect.
Cool. So just array 2 reverse.
Then you have to put a list bracket around the reverse because that gives you it in a list.
But then did you split every single one, or did you split only the first word?
I guess, yeah, the way that I did it would split every single one of them.
Okay.
It would split every word, but I guess you could just split on the first one.
Well, your way's probably, it's all the same. I was just thinking like from my small brain.
And at the end, you could then you rejoin them all.
Did you already submit the solution?
Did I?
Submit it where?
I didn't know if you were following along on Codewars also.
Oh, no. I was just following in the background.
What is
No,
going
just-
on here?
I didn't actually code any of this. I was just thinking about it, so I could be wrong as well. But I think Vinay and I have kind of like a similar idea.
So you put the, you can put, before you split it, put the list in the reverse brackets or parentheses.
So hold up. You're saying
Yeah, before you take any split, do R2 is equal to list parentheses reversed. R1 or so that's the original one was R, so I guess you could equal it to R2.
You changed R.
yeah, I think but like that'll do. Oh, you're right. Hold on. Cool. So then for that, then it's just going to be R2 0 0 is going to be.
Did you enumerate or did you just do a for loop?
I just did a range, and I did I guess if this is the second list, I did R2 I 0 is equal to.
So you hard coded each direction, like each list.
Oh, I don't even think
Because how are you going to change the first and second index then? I'm just thinking,
so
you can do it hard. You can just like code it, or you can try to figure out.
Yeah. So when you do in the for loop, when you get the range, it'll take it from 0 to the length of the list, and where you see where the index there, where he has R2 and brackets 0 0 on that on the first bracket, I put I, so that way, as it iterates through, it'll fill in the first value of the split in the list.
So no matter what, this will be begin. So I don't need that in the for loop, right?
So on R2, you just printed the first one is left. So we want to change it to begin.
Right. But like no matter what, I can hard code that, because no matter what, the 0 0, like so if, when I run this, oh not equal. Why do I keep doing that? Goodness gracious. No matter what, this one's going to be, so now that's going to be begin on row D.
But it might mess up your for loop length.
No, it's cool. It'll be fine.
Okay.
Because now what it's going to be is RI. So it's going to be if
you don't have to put an if statement, because once it's already reversed, you can just replace each one, and it will, since you reverse the directions, it'll the left and rights in that order got reversed. So if you replace it, then it will be left right, since you're going backwards.
But it needs to make sure it does it for every single one.
Yeah, but also look, because I'm beginning on road D, but I'm not changing road C. So begin on road D, I'm going right on road C. The only thing that then is changing here is the left on road B.
I guess we have to make sure we're on the same page on how the directions are changing. And so I guess the way I looked at it, if we look at the original R2 on line 67 on your Juniper notebook. Okay, yeah. I was saying if you go to the right side of your screen where it says R2, the top one. So, yeah, right there. So it says left, right, begin. And so I was thinking the way they change is you get the left, right, begin, you drop it down one, and then inverse it.
So left, right, begin.
Turns into begin, right, left.
But it doesn't. It turns into, oh yeah. Begin, right, left.
No. Yeah, yes.
So you're saying that drops up there,
Yes.
and then everything else flips.
And goes down one because you set it. And I believe that'll happen every single time, regardless of whatever you're given.
Okay, I think I see what you're saying.
And that's why I made the direction list beforehand.
So, okay, I see what you're saying. So let me not do that there. Okay.
So with Vinay's help, we already have all the stuff right. Now we only have to change, I believe, the first word.
Yeah.
And so that's what I was thinking. If we enumerate it, we could. Actually, I don't even think we need to enumerate it. I don't know.
Okay, I think, but okay, I had that photo a second. Cool. So right now we have. So basically, what's going to happen is just all CBA. So basically, what's going to happen is R2 0 0 is going to be that. Like, I'm just going to hard code this out real quick, and then we'll figure out the loop. Then R2 1 0 No. We want to do it almost this way. So we want R2 0 0.
It might be helpful just to do the switch first and then come back and change all of them. Like rotate all the first words first, because then you don't have to, because then the first one's right, you know, and then you kind of figure out, okay,
Hold on. Give me a sec. I'm thinking about, because like we can do this pretty simply. It's gonna be R2 0 0 is gonna become R2 -1 0. Yeah, okay, cool. Because it'll just be I. So that'll be I. And then I think we just do this. If it might be I minus 1 too. Let me think about that for a second. What is this going to do? I don't know, y'all. What do you have, Vinay? Did yours actually work?
So I've gotten to the point where it's reversed the directions, but I haven't joined the list. So, so initially, yeah. So first thing I did was to reverse the string. So I had two strings, one reversed and one original. I split both the strings, and then I did a for loop that would replace the values on that first index from the to the original. I'll just copy and paste my code here. This is the for loop that I used. Send it in Skype or in Zoom, and then I just so this is for I in range length of string split. So string split is the original array split, and then rev split is the reversed string. So yeah, just replacing that index. So just replacing those. And then after that, what I did was I just did another for loop with two if statements or an elif statement here. And paste that in here like this. For I in range length of string split, if rev split I is equal to right or left, I flip it to right. And if rev split I is equal to right, and then I just printed that out. And then I guess I didn't know how to join them or join the strings. I guess that would be the last step.
Cool. Let me get this situated real quick, because we can join it together if this is correct. Okay, so right now your string split is basically the same as my R. All right, and then your rev split I is my R2, right?
Yeah, that's what it looks like.
And then that's going to be string split, which is R1. And then you're going to go ahead and print R2. Okay, let's see what happens here. So now if I print R2,
I don't know why you have all these begins in the front. Did you replace the begins?
oh, maybe let me just redo my stuff real quick. That's why. Okay, so begin, right, begin.
That last one shouldn't be begin. I replaced that one.
Is that what yours is printing out?
No, mine's first one is begin, and then the last one is a direction.
Okay, it might have to be how I'm doing my logic up here. So what did you do? Did you reverse before?
Yeah, I reversed before I split.
Okay. So we have AR.
But I don't know if it should make a difference if you reverse it afterwards.
List. Reversed. Yeah, I don't know either. R. And then left, right, begin. Okay, well,
It's weird.
I think we'll scrap this one for now. We're close. It's just something with the logic. I'd have to like sit here and actually think silently for like probably 15 minutes and kind of go off of what I was doing earlier, but that's kind of boring. So what time is it? 11 o'clock. All right, we'll try one more. Or one or two more, we'll see. And then we can get, I guess if y'all want, I can kind of walk you through a little side project I'm working on. That would be a little teaser for reinforcement learning. But it's basically like you guys already know all this stuff. It's kind of cool. Like y'all know everything if you know neural nets pretty much, which y'all know. And it's just like kind of cool advanced stuff you do with that. All right, let's see. Anything popping out? Going to the cinema. Let's find a popular. All right, let's do that. Mumbling. Let's see what happens. All right, this time, no story, no theory. The example below show you how to write function, a cum. So A, B, C, D, A, B, B, C, 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 D, 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 D. Okay, so it looks like basically based upon where the letter is indexed, you add 1 to that, and then that's how many there will be of that letter, but the first one is capitalized. So that's cool. So S is a string. So I'll do S is going to equal list S. Okay, I'll just do this over here actually. So we can code it and see what's happening. So S equals that. And then S is going to equal a list S. I always do that. Cool. So should see that split up. Cool, cool, cool. Okay. So then all right. So I'm going to enumerate. So for index letter in S, X IDX equals letter times IDX plus 1. All right, so what that's going to do, I think, if my logic is correct, is basically that's going to give me all my letters that I need, and then like the number, the letters I need, basically. You'll see. I don't know. Obviously, I didn't do a very good job explaining that. Not enough values to unpack. Would maybe be useful if I actually did enumerate. Sometimes my brain works faster. So I should see A, B, B, C, C, D, D, D. Cool. Now, real quick, what I can do is S equals I dot, I think it's title. I'll have to go look that up. I dot title for I in S. I don't think I need to do that in the for loop though. Let's see if that works. Yeah, buddy. And then basically what I will do is return s dot join. And this will relate to what I think you were talking about earlier, Vinay, how to join the thing back together. So s dot join, and I'm going to join, looks like on a dash. So dash. And that should get me, I forgot. It's this is the syntax. Boom. Sorry, scrolling. Cool. And that looks an awful lot like that. So I think what we can do is copy that. Paste it in here. Don't need that already. S equals that. Don't need that. That's going to be that. That's going to be that. That's going to be that. We're going to return that. I think that's it. Let's test her. Cool. Cool. Let's go check out some solutions. That was a lot easier, huh? Sometimes they fit in your wheelhouse, sometimes they don't. I will solve that other one though, and I will provide the solution in Slack because that is gonna eat at me forever. Any questions on this one though? That one's pretty straightforward. Y'all probably were thinking along the same lines. Any methods there that I use that I guess the dot join is new one maybe, and maybe dot title might be a new one.
I forgot about the dot title.
Yep, that's a useful. So let's see. So yeah, just some fancy people doing fancy things. So I could have done all of that in a for loop or in the return. Yeah, that's cool. Very, very cool. Cool. Let's do another one. Given the challenge I had with the other 7, I'll stick to 7s for now. Get the middle character. So another string. Are any of y'all doing any kind of NLP for your capstone? Yeah. Cool. So yeah, being familiar with how to mess around with strings is useful. Okay, so you're going to be given a word. Your job is to return the middle character of the word. If the word's length is odd, return the middle character. If the word's length is even, return the middle 2 characters. So kata.get middle should return that, and that. Cool. So we already have S over here, so we can play around with that. So if I want to get the middle, so if length if not, this is a little spiffy trick for y'all. If not length modulo 2. Print true. So this is a way to check if something's even or odd. So like if so length S modulo 2, if it's even will be 0, but 0 would be false. So we want not. So we use not to make it true. Or the other way to do this is just a fancy way to do this. If length S modulo 2 equal 0. Same difference, just a fancy way to do it, I guess. I picked that up from Codewars actually. Okay, cool. So if it's even, we want to get the middle 2 numbers. So if it's 4, I want 2 and 1. If it's 6, I want 3 and 2, right? So basically what I want to do is I want A equals S to S divided by 2. And then B equals S divided by 2. S divided by 2 minus 1. Print AB. S is a list. Oh, that's even better. Geez Louise. Should I have floor divide? What in the world? F string A B. Okay, goodness. Oh. I'm like, what is going on? CB. A. B. A. Cool. And then we'll do else. So if it's 7, the middle one would be 4. So 3.5. So it'd be print or actually I'll just do it like this, return, because this is what it's going to be, return. It'll be S length S modulo 2 plus 1. Also, I think if length S, just to be safe, this might already work, but it might not. So equal 1, return S, just because of this one right here. I don't know. I guess it'll be interesting to see if that'll work for 2. If this logic will work for that. We might have to account for that as well. All right, let's see if this works. Do I need that return statement inside of that? I guess. Test. I should equal to T. So that's 1, 2, 3, 4, 5, 6, 7. So 7 divided by 2 is 3.5. Let's do this real quick. A, B, C, D, E, F, G. Just checking out the logic here. So, okay. So what does that give me? That's interesting. Does that give me 4? Does that round up? No, that gives me, oh, but it's 0 indexed. Brandon, you knew that all along, didn't you? You were just going to let me struggle here, just drowning in my own.
Well, I knew it wasn't a struggle for you.
Okay, thanks, buddy. All right, there we go. Cool. Any questions there? So there, yeah, any questions there? No? So I guess nifty little trick using the modulo this way to check true or false if something's even or odd, and then using floor division to index. So that way you index by an integer. If I were to use just regular division, I have to wrap that into an int. So it just saves you a little bit of code. Cool. Let's see some solutions. So yeah, like my brain doesn't even comprehend what they're doing there. I guess it does. Oh yeah, so they're just indexing. That's smart actually. So they're basically, yeah, they're doing what I did, but then just indexing there, not having to like have it split with the if else stuff. There you go. Similar to what I was doing. Indexing. Cool. Yeah. So yeah, it's also interesting kind of to see like once your mind goes down a certain path, you kind of stick to that path. So like I wasn't even thinking about slicing and indexing that way because I was just thinking about like, yeah, just snagging it individually. So different ways about going about doing things. Cool. Well, I guess my question to y'all would be, do you want me to do another one of these, or do you want me to sort of walk through a cutting edge algorithm called Twin-Delayed Deep Deterministic Policy Gradient, also known as TD3?
Probably that TD3.
Yeah. Okay, cool. All right, let's see if we can get this situated then. So I'm in the middle of, it's a Udemy course. Oh, actually. So it's a Udemy course. Cool. My drive. And I'm in the process of coding this out. I'm using Codewars because Codewars that gives you access to a. Can I open this? Like, there we go. It gives you access to GPUs and maybe even TPUs. I don't know, but it's pretty cool. Cool. So this is what I've gotten so far. I haven't actually implemented the actual logic of running through, but there's some cool visuals that I'll get to. Let's see. Yeah, cool. So I'll full screen this real quick. Okay. So this is like the full algorithm. So what y'all know already, basically, is a lot of this stuff, what's being described. You might not understand the aspects of the states and the actions and then what we're doing with the Q values, but you understand basically what this is. And then I'll go show you the actual architecture, because y'all know this is just a basic neural net. It's a deep neural net. So there's 3 layers. So the first layer is taking the states. So that's just like your X dimension, like, right, whatever your features are. So for one observation. So so in this example, it would be like, well, in this example, it's like this literal state of like a 3D environment, but you could just think of it like whatever data set, whatever data set you're using, that's what your X's are. It's connected to 400 neurons that are just running our basic linear transformations, right? So just like our typical neurons in a basic neural net. Then we're running a ReLU. So that's our activation function to capture the nonlinearity. And that's feeding into 300, another hidden layer. Same thing, linear combination. So adding your weights and biases. And then that's feeding into, then we're running another ReLU on that. And I think we run into another even, I'll have to look. And then ultimately, I think we do a TANH at the end. So that's one network, right? So that's basically what the main network, the model. So then what everything else is sort of it's 5 other neural networks that are operating to help inform that main model network. And so it combines a couple of different things that we haven't gone into and we won't really get into in terms of reinforcement learning. But one of the main things in that we'll touch on is Q learning. And so you can think of just like Q learning, the way they describe it is like grid world. And I don't know, I guess I can show you. We could go to a picture. We could figure out a grid world. So basically, we might have seen something similar to this, but like this. So you're an agent, right? And what Q learning does is it basically helps you figure out the optimal path from there to where, from any state you're in to that point. And then, so basically like what this algorithm is doing is this stuff is doing like some Q learning, getting the Q values. And then we're using these as a target. And the reason that Twin-Delayed DDPG is revolutionary is because it can work in a continuous action space. So when like your actions like are almost like you have multiple actions and you continue to make actions. Because it's like in a continuous space, right? And you can think about this in terms of like discrete versus continuous, like probability distributions. If in a discrete space, I can, when I actually have an in state, like, so like this would be an example of discrete space, right? I have an actual in state that I can get to, then I can work my way back. I can actually figure out the actual Q values. The problem in a continuous space is like you'll never know what the ultimate end is, right? So like if you think about like trading, right? Like you don't have a final destination in terms of like, oh, this is my goal. You're always kind of doing it. And so what this does is these sort of predict Q values, like optimal Q values. And one of the problems with like the deep deterministic policy gradient is when they were using it, they would take the maximum of these. So it's almost too optimistic. So it would almost overfit, or, it wouldn't predict well. So what these do is these come up with like 2 Q values, which are like basically you can think of like your return or your reward, right? So if I'm trading, it's my reward and my return on my investment, right? If it's that game, if I'm in a continuous space, it's like the reward I get for learning how to walk or something like that in robotics. And so that's what the Q values are. So these are predicting Q values. And then we're using these to get as close to that Q value the minimum of these Q values as we can. And then we're doing our loss. So just like in a normal neural net, right? We're getting this is like regression, basically. We're trying to do regression to this Q value, which is our main squared error, which y'all might not be able to see very well. But like, so it's MSE of the Q values. So then we use back propagation and we use stochastic gradient descent, the atom optimizer, to update these values. And then this is where the policy gradient aspect comes in, because, and this is something that we haven't really gone over, but it's very simple if you think about it. We've gone over gradient descent. So we all know sort of what gradient descent is, and because we're trying to find a local minima, because we're trying to minimize something. Well, policy gradient, and in this aspect, we're trying to maximize this Q value because we want to get the most reward as possible. So you just do the inverse, and it's gradient ascent. So you're trying to go and find the maximum value. And so that's kind of like what you're doing. And then the reason it's called delayed is because you only update this model every 2 iterations through. And then sort of the cool thing about like this model and this model is they're similar, but they're different. And so one of the really cool things that the researchers, when they were doing Twin-Delayed DDPG, figured out is, so basically what we do is we let this actor model run randomly for like 10,000 actions. Because what we have to do is sort of build up what's called an experience replay memory. And so it's like, think about you're a robot and you're in a game and you're in that grid world, right? So we're in that grid world space. And I'm just exploring for 10,000 random iterations just to get up some memory, because that's what we're going to use to figure out some of these Q values. Because then what happens is we get these weights that are sort of, we don't really update anything. We just kind of get these weights. Then when we start the algorithm, we use these weights to do this. And then we get through this and we get the states that we're in. So given the state that we're in this is going to predict for the next state, because that's what's going to give us these next Q values. So this is going to go into the next state and predict what the optimal actions for that state is. So it's almost like one step in the future. Then these are going to take those states and those actions and then determine what the Q value for that next state is, right? And then this one does that, and then this one does the same thing because we want 2. And then we're taking the minimum of that. And that's what we're doing to update these, given the current state we're in. We predict to that Q value for the next state, because that will be, that's how we determine what the state of this value is. And then we go back here. And then so every 2 times we go through this, then we're updating this with this is the formula for the gradient ascent. And then what we do actually is something that's interesting. So in a lot of algorithms, they just would transfer these weights to this weight. But what they figured out is this thing called Polyak averaging. And so it's this formula right here. And basically what this is tau is like a really small percentage, like 0.005. And this theta are the parameters, so the weights for all of this. So we're taking a really, really small percentages of these weights. And then we're subtracting 1 minus that tau. So we're taking the majority of this theta prime, which are these weights, and we're adding those together. And so that way, like slowly but surely, these things will converge as we do more and more iterations. But this is sort of like learning on its own in a different way. And then also like learning that way. So it gives you a little bit more randomness, a little bit more variety and exploration. And so like, I'll just go through the code a little bit. So this is what I was talking about in terms of the replay buffer. So that's like the experience replay. And so like the actor model, the very first one, the one that is our main model, we just let that run for 10,000 things. And this is where we're getting like storing those replays, because that's like those, by exploring that space, he's getting information of the state that he's currently in, the actions that he has available to him in that state, the reward for the state that he's in, and then the reward for the state that like the next state. So like basically something along those lines. And you can kind of see that here. So we get current state that we're in, next state, action for the current state that you're in, the reward, which is a function of like the Q value for the next state, and then whether or not you're at a stopping point. And so like we let that guy run for 10,000. Then we have these 10,000 experience memory replays. And then that's sort of what we do. And then here we're building the actor models. And so we have so we're just building a class, and this is cool because it kind of goes through, like, I would never do this on my own, obviously, like just build a class like as I'm coding, but like that's how he kind of has it done, because like it actually, like, it makes sense. It's like, oh wow, this is super useful, because I'm going to need 2 of these guys, but I'll have this class and they're the exact same. It's just like one is going to be the model that I'm using, the other is the target. And so, like I was saying, so we have a initial layer, which is the number so the state dimensions. So that's just the dimensions of the things that we're feeding in, those S states. And then that's going into a 400, right? So here's my 400, and then my 400 is going into a 300. And then my 300 is going to be going into my like actions, which is like the number of actions I can have. So like in the grid world, I can go left, up, right, up, down, right? And then so based upon whatever environment you're in, the action dimensions is like what your targets will be, because you're trying to figure out what your optimal action to take is. And then you see here this forward method. This is us like feeding it forward. So we get the X, which is going to be our states, and we feed that through the first layer, and then we're running the ReLU function on that. And then we feed that into the second layer, and then we feed that into the third layer, and we're using a tan-H function on that. And then this max action, it's like to clip the like max amount of actions you are based upon the environment that you're in. Sometimes like if you don't clip it, you might have an action that is not able to be taken in that environment just due to maybe randomness or something like that. I'd have to dive in a little bit more. There's a paper that if y'all are really interested in this, I can give you some resources. So then it's almost the same thing for the critic. So we have 4 critics, right? We have 2 target critics and then 2 model critics. And so what we're doing here actually is we're just creating the 2 critics in the one class. So this is 2 neural networks, but in one class. So that way we only have to do 2 of these. So we'll basically have an actor model, an actor target, and then a critic model and a critic target. But the critic model and the critic target are 2 neural nets inside of one. But it's basically the exact same structure. This time it's the state plus action dimensions, because in the other one, we're taking in these critic models and targets, we're taking the states and the actions as our inputs. And then, but it's basically the same, another hidden layer to 300 and 300 to 1, because we're trying to predict 1 Q value. And then we're doing the same thing for the second one. And then the forward is very similar. We're taking advantage of PyTorch and some of its features, and that's just concatenate. So just like Pandas data frame concatenate, this is their version, and we're concatenating the X and the U. And the reason we're taking advantage of PyTorch doing that is because I believe in order to be using PyTorch, your data actually has to be in a tensor. And so that'll get us into the tensor. And then the same thing here. So ReLU, and then we're just gonna actually just predict to the value. And then we're returning the X1 and X2. And then this is where we're getting into actually creating the process of where we're going in, getting the batch, feeding that through, and sort of building out the algorithm. So I'm at that portion now, but you can kind of see like first we're knitting a whole bunch of different stuff. It's kind of cool too. This little line of code here is what allows it to determine if I want to send it to the GPU or the CPU. And then by having like this to device, it will let me tell it to either send it to the GPU, or I can specifically send it to, I have it somewhere. I can send it to CPU. I must not have coded it. I must not have it saved. Oh yeah, to CPU right here. So you can like, the reason for this is like, this is a really simple basic operation. So like CPU will just crunch that number fine, but then you can like specifically, like when actually running the neural net, I can send that to the GPU, which according to the guy, like I could run this all on CPU, no problem. So yeah, I don't know if any of that made sense to y'all, given what you know now, but maybe it does, or at least it's like an exposure to like, all right, this is sort of what you can do with these neural nets and string them together and get like crazy, super awesome results.
Yeah, that's pretty cool. I mean, I don't know, like you said, I don't know everything that's going on, but the stuff I do know is it's like, oh, that's awesome. I don't know you can do that. So are you doing this for like for a project or like for funsies or?
Yeah, what my plan is like, so also like, I wanted exposure to this because like when we get into reinforcement learning, this will give you already some framing to be like, oh yeah, that's what Justin was talking about, the Q learning, and like, oh, okay, cool. And so like, that'll just sort of fit into place a little bit better. What I'm doing with this is like, because we have a reinforcement assignment, but it doesn't have a solution, or I don't know if it does. I don't think it has very many solutions. It has maybe one, but like the more the merrier. So I'm going to try and do this and like do a basic deep Q learning, which is like what we probably do in the assignment, but then also have this model as well. So, and then like share this code so you guys can have like, y'all can play around with this, like have two. So you'll have like the more basic deep Q, which isn't basic, but like basic compared to this, and then you'll have this as like the advanced, and then maybe even like compare and contrast the difference. But I kind of wanted to do it so like this does it for the human, and like actually I'll show you all the video real quick because it's kind of cool. So this will do it for like so like this is one of the hardest problems. Hold on. But like this is what the DDPG does. It like teaches this thing how to walk from nothing, which is like a really, really hard problem. It doesn't seem like it is, but like it's one of the hardest problems that are out there, I guess, in robotics or whatever. So that's what the DDPG does. And so like we can do deep Q learning to show you how like deep Q learning will compare to this. And for these different ones, like here's the humanoid, which is pretty cool. But I kind of want to do it for like blackjack also. And I don't know if I can even do it for blackjack, but I think that would be fun. But yeah, like in the early training, when you like watch these videos, it's just like the thing is just like, so, yeah, this is something for y'all to look forward to.
Would you recommend this course? Because I see it's 90% off right now.
On Udemy. Listen, yes. I used it, and so like I don't want to like if you're cool spending money, I would definitely recommend it. But I will say this here. Let me send this out because this is actually probably better to get started on, because I think you can get the same basic, like the course is cool because it's like it'll give you the object-oriented program aspect of it, and like I need more exposure to that, so that's why it's good for me. I get kind of double-sided on that. But if you just are interested and you want to play around with it, Twin-Delayed, yeah. So I would go check out this website, and because it has like a bunch of stuff, a bunch of documentation, and kind of it would give you the idea of how to sort of implement this. And I'll send this out to oh, cool. Did Kiara leave? She figured out a solution? I just saw that. Awesome. Awesome job. She's good. She could probably live code better than me. But yeah, so I would check that out, play around with it. I mean, I'm telling you all right now, like this course is a lot of fun after. Like, well, obviously there's like the stress of getting the job, but it's fun to like, oh wow, you have this skill set. Now you can like actually like go and read a paper that's like on a super advanced algorithm and like actually have it make sense. And then like you can read a bunch of different papers and then like really reinforce your learning. Because like the cool thing about the Udemy course is he actually like mentions a bunch of different like resources. So like I have a bunch of different of these PDFs of like different papers that relate to this. So then going in, and if you actually start reading those, right, then you're getting like multiple synoptical perspective of this space, and that's how you like kind of master it, you know. I don't know if you're like me and you're a nerd and have nothing better to do with your life. How y'all doing though? How's solo week? Anybody working on their capstones?
I am. I was just ran my first CNN this morning. Or I've been running a couple versions of it, but it's taken a while, man. It's like 10, 15 minutes. So I think I need to switch over to AWS and get some.
Oh, hey, actually, I was just
power
showing
on.
them. I think you just popped in. Let me share my screen again. I think if you want to play around with the GPU, use Google Colabs. This is a Jupyter notebook and a Colab, and then right here. And like you can, so I'm using PyTorch, but you can use TensorFlow, and you can select the runtime here and change runtime type. And I can select GPU or TPU. I don't know how much time we have on GPU and TPU, but, and then like, that'll make your training so much faster. And so like for PyTorch, I was showing them earlier, I have this little line of code here, and I know for a fact TensorFlow probably has something similar. And so I can run this line. And so if I have the GPU selected and it's available, I can run GPU or also just run CPU. And then when I'm actually building out my model, so like this is just an object class, but this would be similar to you building out your model. I'm sure TensorFlow has something similar where you can do like 2 device, and then so it'll automatically.
Sorry, I was just saying, okay.
Yeah.
Do you have thoughts on PyTorch versus TensorFlow?
They're not my own. So I have thoughts of other people's thoughts.
Okay.
Which is PyTorch is probably the way to go. But I don't know. I don't think you can go wrong either. And especially learning, like they're like curious in the documentation and just like the environment they have over there, and how like it directly, you can go and get Colab libraries for Curious and all that. So, and if you're doing convolution nets, dude, Danny, this week might be fun to just go like explore a bunch of these different Colab already pre-made, done Jupyter notebooks and play around with the CNNs that you already have. And like you could do transfer learning even.
Okay. Yeah, I was kind of thinking I'd, hand build one from scratch and then go pull some off the shelf and run them against them, so I can show my shitty version versus a, production ready version.
I love that.
Just to show that, I don't expect to be building CNNs by hand when I get a job. I'll be just running them, right?
No, that's like one of my buddies, Lester. He was at our last capstone. He did that. He like did his, and then he had like the transfer learning one and showed the difference. His wasn't very accurate though, either one. So like, don't feel bad if you're not getting. I heard you say earlier they got like 31% running your first one. Like it's tough, dude.
Shoot, I'm up to 60% now.
There you go.
It's just taking so long to run that. I mean, I imagine I can keep getting it up there. But then watching, I haven't made that curve yet for the loss or accuracy yet. So, but yeah, I'll check out Google Colabs, man. Then, because if I can, or at least see if I can get the GPU and all that set up in Keras, because it's dragging, just taking a long time. I figured I'd just spin up something in Amazon and some kind of monster and burn all my credits.
Yeah,
quickly as possible, and start slinging them through there.
I won't name names, but there was someone in my cohort who left the very expensive EC2 on overnight and woke up to $1,000 out of his bank account.
Ooh.
Had to call and get them to refund. They did. It wasn't that big of a deal, but whew.
Yeah, I would poop my pants if I did that.
But also, I guess real quick, if you're thinking about doing that and spinning up an EC2, do you want me to run through my workflow of how I kind of do that in VS Code?
Yeah, because I have zero idea how I'm going to do that. I'm just going to
Cool.
go start looking at YouTube's videos.
All right, let's do it.
Because I feel like it's an important, it's a good time to show it, because if we especially need it during Capstone 3.
I'm still sharing the screen, right?
Yeah, as our data sets get bigger, I feel like I should just learn to use it now while I have a little bit of time to do so instead of.
No, dude, and that's exactly right. Like, just bite the bullet and just bang your head against the wall now while you have free time and just explore.
Mm-hmm.
So that way, what? All right, EC2. Okay, so first off, you gotta like, when you make sure when you like spin it up, you have your PIM file, and you know where that is, because that's important. Well, like when you spin one up, it'll have you download a PIM file, like a .pim, and so just save that somewhere where you can remember. Mine's just on my desktop because that's the easiest for me, but I'll highlight where that comes into play here in a sec.
Okay.
So I already have an EC2 that I like to use that already kind of has all my stuff on it, so I'm just gonna launch that. These are cheap though, like both of them. I can run this for like 24 hours. It's only like $3 and they're pretty good. So I'll just run this one. So like the reason I saved it.
Thanks, Alvita. Sorry.
No, you're good. Sorry, my stomach hurts. The reason I saved it is like I had to add like download a bunch of libraries and that kind of thing. And so like I know Dan talks about like their cattle, treat them like cattle, not like children.
Mm-hmm.
I kind of treat mine like children because like I had to do a lot of shit to like get all the libraries and different things that I needed on this one. So like it's cool to keep one. Just don't like be attached and have like something that's like important on there. Like always be updating to GitHub, which I'll show you how that's very simple using the method I'm about to show you.
Okay.
Cool. So I'm gonna launch this bad boy. No, not that. I'm going to start that instance. Cool, refresh. All right.
So as you're building an instance, does it, once you build it, will it tell you like the time or the cost to run it over time, or how does that work?
Yeah, it'll like show you it. Like there's a way to check out the pricing. You can also maybe get like full-blown estimates too. But I haven't really messed around with that. I just kind of risked it on this one, and turns out it only, and I forgot about it, so that's how I figured out if you run it for 24 hours, it only costs like $3.
Okay.
All right, so yeah, so now that's running. So I'm gonna hit this connect thing, and the only reason I'm doing this, so it's Ubuntu. I need to remember that. SSH, cool. So I want to copy this. So the first thing when you get your PIM file, you will need to run this in your terminal in order to make sure that it has the right permissions, which remember it's like 4 is me. So I have like all read write and everything, and then 0 is just like anyone else on my computer. You don't want, I guess it's just like for safety.
Okay.
So then I'm going to copy this. Okay. And now what I'm going to do is I'm going to go to VS Code. All right. And then, so what you're going to want, and you might as well just go ahead and do this now, is remote development. You want to just install this because it'll give you WSL containers and SSH. I haven't messed around with containers, but it allows you to like connect to a Docker inside of your thing. But I think you can just connect with Docker anyway, so it's kind of superfluous. So if you really just want, you can just get remote SSH. That's really all you need. But I just did the remote development, but it's either remote SSH or remote development. Once you install that and get that up, you'll see down here in this window, like I have this little blue thing, and I click that, and then up here, it's gonna say, connect to host and open configuration file. So I think if you don't have a configuration file already pre-made, it'll make it. If not, just hit me up on Slack and I can give you what it looks like. So I'm gonna go, it's gonna be the one that I have in .ssh on mine. So this, if you see this, that would be on the EC2, I think. I'm not sure. I don't know where that comes from. Maybe random trash I have in my stuff, but so
Okay.
I'm gonna go to that file. So there's my name of my computer, or my name of my host, which I'll explain here in a second. So this is the host name, and that's where I'm gonna paste the thing I just copied. So this portion right here, I copied that. Ubuntu, that's the username. So making sure that, and then this is where my PIM file is. And that's why it's important to know where your PIM file is. So once I have that all saved, I can just hit Alt save and I can close out of that. And then I can hit this and it's going to say connect to host. There's the name of the host, like from my configuration file. I click on that. It's going to open up a new VS Code. It's going to ask that. I'm going to hit yes. You just got to be careful. Sometimes it will disconnect. And so if you're not like updating that kind of thing, that can be a problem. But so now I'm connected. You see down here, I see SSH is EC2. So then on my EC2, I can go open my folder and I have this there. So now I'm in, this is my project, my Capstone 2 project. So you see I have this. Here's my GitHub, right? I can automatically update my GitHub from here and not have to like worry about saving on my EC2 and that kind of thing. It'll automatically update. But yeah.
So how did you get to your GitHub? Go back. I think I missed that.
So this is your source control for VS Code.
Okay.
And so if you don't have this set up, you can just click on this and it'll have you type in your username and password for GitHub.
Oh, I see. Okay. Yeah,
But
yeah.
yeah, man, this is
Nice.
this is how I did. I had a really old laptop, like a 2009 MacBook, and I did this entire project on that laptop through an EC2.
Nice. That's not so bad.
Nah.
Hooking to it.
And so yeah, and then that's that.
Nice. And then how do you disconnect?
I just closed out of that, and then I'm just gonna go back here to my instances, and I'm going to stop instance.
Okay. Sweet.
Cool. So yeah, between that and collab, you should be straight.
Okay. Yeah, I think that'll help. This 10 to 15 minute runtime's gonna get old quick.
Yeah. So other than that, you got any other questions? Anything else? Any tips, tidbits?
Oh man, I think I'm good.
Was that useful?
I think so. I feel like I'm just gonna try to get all my code, everything written up locally and ready to go, and then have a few different versions of the model that I'm, can bang through, and just start training them and doing everything on EC2 after that. That way, I just, not coding while I'm on, connected to an EC2 server, wasting time. I think that'll work.
Brandon, was the like Codewars stuff useful?
Yeah. I mean, I didn't do the first one before, and I got my stuff to work for 2 of the 3 cases. And then your second and third example, I completed before taking this course, and it was all helpful. It would have been helpful back then too.
Good, cool. Well, I guess if that's the case, like I can probably do more of this and probably do a little bit better job. I don't know. Yeah, something to think about. Cool. Well, if there's nothing else, I'm gonna chill for. I'm gonna go grab lunch, but I'll be on this afternoon. I don't know how office hours works, but I guess like if y'all run into any issues or need anything, hit me up on Slack. You can either direct message me. You can do a help desk ticket, but you can direct message me as well.
Cool
I
beans.
could use
Thanks-
some
thanks.
feedback, but I don't want to get in the way of lunch, so I can catch you after lunch or whatever. I'm just hanging out at the house, so figure I'd check in. But it might take a second.
What are you trying to do? Yeah. Well, okay, we'll dive in.
Yep.
Let me
What
go-
time? Do you have? So I was trying to figure out. Are there appointments? Do I need to make an appointment during these like blocks of time on the Google Calendar, or
I'll just Slack you.
okay, that sounds good.
All right, thanks guys. I'm gonna grab a bite to eat too.
See you. Thank
Yeah.
you for your
See you out
time.
here in a little bit.
See y'all.